Hello and welcome to this tutorial on PI Expert version 9. In this tutorial, we will walk you through a basic design and explain some of the changes we have made to the software along the way. Let's start off by doing a TOPSwitch-JX based design. Let's select the new eSIP package from Power Integrations. For the TOPSwitch-JX family, the switching frequency is programmable. You can choose between 132 kHz and the 66 kHz option. I'll leave the switching frequency at 132 kHz for this design. The enclosure is a way of specifying the thermal environment of the power supply. For example, if the power supply you are designing will be enclosed in a sealed plastic case, much like in a cell phone charger and other external adapters, then you should choose the adapter enclosure type. On the other hand, if your power supply will be housed in an enclosure which allows for more free airflow, similar to that of a PC power supply or that of a DVD or set-top box power supply, you should choose the open frame enclosure type. For this design, let's select the open frame enclosure. You can specify a feedback type from the available options. I'll leave this selection as secondary TL431 for this design. Click Next. This takes you to the AC-DC input type dialog. On this dialog, you can specify the input voltage range and the frequency if applicable. For DPA switch applications, you can choose the input range from this low voltage DC input section. For this design, let's select the universal input voltage range. Click Next. On the DC outputs dialog, you can specify the output voltage and current. You can specify up to 6 outputs. Check this box if you will be specifying peak loads. To add the first output, let's click on the Add button. This dialog allows you to add the output voltage and current as well as the allowable tolerance on the output voltage. By default, the tolerance is set to plus or minus 5% for output voltages less than 6 volts and to plus or minus 10% for all other output voltages. Let's specify a voltage of 5 volts at 2 amps. Let's specify a second output, a 12 volt at 2 amp. Notice how the output voltage tolerance is automatically updated to plus or minus 5 or 10%. The absolute min and max voltages are also displayed. These voltages are centered around the 12 volt set point. Click Next. That's going to take us to the Design Settings dialog. In the Design Settings dialog, you can specify which component set the software can use during optimization. The default component set contains components that were included in the software during installation. As you add more and more components, these will be automatically included in the All Records component set. Let's leave the All Records component set for this design. In addition to other controls on this dialog, you can also specify units, American or SI, and ask the software to use shield windings while coming up with solutions. Let's click Finish. This begins the optimization process. The Solutions Filter dialog allows you to specify how many solutions you want the software to remember and present to you at the end of the optimization run. Additionally, you can control how many turns on the main output winding the software can try and iterate through. And finally, you can control which core size the software can start from and which core size the software should end at as far as generating the viable design combinations. For example, I can ask the software to iterate from 1 turn all the way up to 10 turns. And I can ask the software to end at 1 core size higher than the default while generating the results. Bear in mind that increasing the turns or the core size will increase the combinations that the software will have to compute and may result in slightly increased runtime. Click OK. This starts the optimization process. After optimization is complete, a list of top solutions are presented to you. the best design on top. You can select fields you want to see for comparing the solutions by clicking the Fields button. The Normalized Output Tolerances column gives a quick visual representation of the actual output voltages at full load. So, if we compare solution 1 and solution 5, we can see that solution 5 has the 12-volt output on the lower side of the desired set point, whereas solution 1 has it slightly higher than the desired set point. You can make a choice of which solution fits your need the best using this information. Additionally, you can compare core sizes and other important parameters between the top solutions from this dialog. Select the solution you want to view for detailed information and click Open. I'm going to select solution 1 and then click Open. The schematic view shows a detailed schematic for the specification requested. The schematic is interactive and component values can be changed directly from here, either by double-clicking on the component to change it directly through the database, or by right-clicking and opening up the functional dialog. You can zoom in to see more detail and then pan through the schematic, or you can zoom to fit to see the entire schematic all at once. The Design Results tab tabulates detailed information on the selected design. The Transformer Construction tab contains information on prototyping the transformer. This includes the transformer electrical schematic, mechanical construction, and detailed winding instructions. Other tabs list more information pertaining to layout recommendations and complete BOM listings. I hope that this basic tutorial has been helpful in understanding how the software works, and we hope it will prove to be useful to you in your designs. Good luck.